Hi, welcome back. Welcome back to Rebar Detailing 101. This is our second lesson, and today we're going to talk about practices in the industry as practice in the United States. We're going to talk about fabrication and dimensioning rebar. In fabrication, the present standard fabrication and plate equipment have the following limitations, and the industry recognizes this and made their own recommendations. For example, in rebar detailing, the dimensions of the rebar are incremented in quarter inch only, 5 millimeter in metric, only quarter inch. The equipment that is used for bending and shearing are all calibrated to quarter inch only. So there cannot be an 8, 3/8, or 7/8 in a bar dimension. All the bar dimensions are quarter inch, half inch, 3/4 inch, or a full inch. In sheared lengths, that is straight bars, the total dimensions is rounded up to the nearest inch only. There are no fractions allowed, only full inch. Everything is rounded to the full inch. Fabricating rebar is a costly operation. The cheapest one, of course, will be just strictly shearing of the bar, shearing or straight bars. Straight bars is the cheapest to fabricate. Mainly, all you do is put a series of bars, several quantity, put it on a shear machine, shear line, and they're sheared up in one operation. So there's just one operation, shearing. So shearing is the cheapest one. The most expensive is light bending. That's why the name came from, light, which means light in production. Very light in production. One, because most of the bars that goes into that category are all the small bars, the number 3 bars, for example. In fact, the definition of light bending are all number 3 bars that are bent are light bending. All bars, no matter what size, used for stirrups and ties are light bending. If it's a number 8 bar, used as a stirrup or a tie in a big bridge, that's light bending. All number 4 through number 18, which are bent more than 6 points, there are 6 bending points, more than 6 bending points, or more than 1 plane instead of 1 plane, 2 planes. These are all light bending. Bars bent with more than 1 large radius is light bending. A combination of a large radius and other bends, that's a light bending. That's the most expensive one. The second most expensive one is heavy bending. Heavy bending are bars number 4 to number 18, which are bent no more than 6 points. These are heavy bending. Special bending are all bending to special tolerances, and they are priced accordingly. While the knowledge of fabrication classes applies more greatly to rebar estimators, it also helps the detailers if they know the different types. It will help them determine which bar bends to use. I will explain this later. And also it helps them make their own bend types. When you're asked to make your own bend types, the first thing it asks is, are they going to be light, heavy, or special bend? Fabricating machine, a radial fabrication machine, when you're bending a bar into a radius, there's a certain limitations on the fabrication. Bars have a tendency to spring back to its original shape up to a certain radius. For example, the number 3, they say you can bend it to a radius of 5 feet. Greater than 5 feet, you might as well send it straight because it will spring back to straight. So 5 feet radius, a total length of 10 feet. And number 8, if the radius is 60 feet, you could bend it. Greater than 60 feet, you might as well send it straight. So this is what this table means. Rebar fabrication table shows the maximum radius and length of bars that will require fabrication. Beyond this table, bars are furnished straight. This is all due to spring reaction of the bars to radius bending. Okay, now we jump to chapter 6. In chapter 6, it shows a table that shows the actual diameter of a bar, including its deformation. A detailer needs to do this. You use this in calculating clearances and spacing of bars. If you want to know the certain clearances or the spacing of the bars, you use this table to calculate it. Imperial size bar in the United States are divisible by 8. To know the diameter of the bar, all you have to do is divide it by 8 up to a certain size. For example, number 3 is 3/8 in diameter. 3 divided by 8 is 3/8. Number 4 is ½ inch bar diameter. 4 divided by 8, or ½ inch. 5 is 5/8. 6 is 3/4, because 6/8 is 3/4. 7 is 7/8 diameter. We're a little bit too look at this, the difference. We have number 3 and number 4. 3/8 to ½ inch, only an 8 difference. And then another 4 to number 5. That's only an 8 difference. 5 to 6. We have a lot of those. So that's why we have more bars, 11 bars against metric. Metric is just 8 bars. So they have a better use of the diameter. So in essence, we really could eliminate maybe 3 or 4 and just jump to 3, 5, 7, on all that. But this is what we have, and this is what they use. Engineers are so used to using all 11 bars. You can imagine the shop having to have all these bars in their inventory. Sometimes they end up with a shortage of the small size and an abundance of the big size. On 6.3, page 6.3, shows the typical bar bends. These are the typical bar bends of the Concrete Reinforcing Steel Institute and ACI. The software that we use, Year 97, has more bar bends than this. Each software company developed their own types, but all of them, almost all of them, will always adhere to the types made by ACI and CRSI. So this is not the complete set. You have to refer to your software, the detailing software that you use. You will notice a bar dimension A and G, always A or G. There's A or G. G, always you see A, you see G. A, and then you see G. A, you see G. A or G are standard bend dimensions. They made that specifically for standard bends. Now let's look at the standard bend. you notice the table on standard bend, these are the standard hooks. There's a table, there's a column for A or G. For example, 180-degree hook, number 3 is 5 inches, number 4 is 6 inches. It's always like this. A or G will always be like this. That's the A. J is an outside dimension. On a 90-degree hook, again, there's a column for A or G. That means A or G. For a number 3, 90-degree hook is 6 inches. Number 4 is 8 inches. You can imagine the predicament of a rebar detailer having to memorize A or G. Well, luckily, the software company and CRSI ACI already took this into consideration when they put up the standard bend types. So each time you use a type 1 on your computer and it's asking you for the dimensions A, B, or G, you don't need to enter from your memory what A or G is for that particular bar size you're using. All you have to do is hit a key, a designated key. In C97 it's the minus sign. If you hit a minus sign, the computer will come up with the standard A or G dimensions for that particular bar size. So you don't need to memorize it. Because once you see A or G, you click it. But when you go to B and you click the minus sign, nothing happens because B is not a standard bend. That's any length. So the only standard bend is A or G. And this is the reason why you use a type 2, in this case, which is a U-bar, against a type 17. A type 17 is also a U-bar. But you notice type 17 doesn't have A or G. It's B, C, D. B, C, D is not a standard. That means you have to supply that dimension. Unlike on type 2, all you have to supply is B. A or G, the computer knows. That's why A or G is designated for standard bend. So when the other thing on bar bend types, all the dimensions except the hooks are out to out. For example, look at this. B is out to out, out to out. One corner to the other corner. So outside this, outside that. H is out to out. Everything is out to out. You cannot be center to center. It's always out to out. That's the rule of the jungle in rebar detailing. The other thing also, if you look at the type, if we go back to the type, to find the length, the nominal length of the bar, all you have to do is add the dimensions. For example, you want to know the total length, this type 1 bar, all you have to do is add A, B, G. Add A, B, C, D, E, F, G to get the 3. A, B, C, D, F, G. Yeah. In rebar detailing, you add all the letters up to G, added together to determine the nominal length. I'm saying nominal length of the bar. H and O are never added, like H and O. They're never added to the length. Because H and O are outside, they are external dimensions only and not added to the determined length. Numbered types, bend 1, 2, 3, 6, and are mostly heavy bent bars, while S and T types, which is S1, S2, the S and T types like this T, to are light band bars. So by selecting the type, it determines whether the bar is heavy and light, so that they could, when they price the order, they will know what price unit to use. If you use the wrong type, they will now be lost in their pricing. They won't know the actual what to price it to. For example, let's see, one example I can show you. Look at S11. It's a U bar. That's S11. And now let's look at, wait, S11 against 10. It's also a U bar. Which one are you going to use? If you use 10, then it's a heavy band bars. The pricing on publication is almost like this. Straight bars are priced $5 per hundredweight, or for every 100 pounds they charge $5. Light bending is like $50, 3 times as much. Heavy bending is only 10. So 5, 15, and 10. So if you have a type that's a U and you use type 10, then they will price the order as heavy bend. But supposing that U bars is going to be used as a stirrup, like S11, you should have used S11. That way the weight will be multiplied to a light bending price, which is $50 per hundredweight. See, the wrong use of type will throw off the pricing of the material. So the detailers are obligated to know exactly which type to use, which is heavy bending and light bending. That's how important it is. It's not just to the estimator, but also to a rebar detailer. And if you're creating your own special type, you have to know whether that special type is heavy or light. The other rule in rebar detailing types is that you don't have to use all the members of the type. For example, if I need a right angle bar with just one right angle, I can use type 17, and I will just enter B and C. No entry on D means it's just an L bar, not a U bar. But if I had an entry on D, then they know. So the rule is you don't need to use all the members. So you don't need to use all the members. For example, you could use this for B, C, D only without the A or G. Like B, C, D. But now you got a problem. You have two types that you could use, because all you need is BCD. BCD here, BCD here. In fact, BCD here and here, they're all the same. So in essence, if you only need BCD, you could use type 3, type 4, type 5, type 6. Because all that shape is available in all those types. But there is a rule. Remember, all these missing dimensions are in the computer. When you task the computer to make the calculation, the more numbers it crunches, the slower it gets. So it behooves you to give the computer the least amount of dimensions to crunch. So if all you need is BCD, choose the type that has least number of members to delete. For example, between this type 3, all you need is BCD. Between 3 and 5, use 5 because here you only have B, C, D and you're just eliminating A or G. Meanwhile on 3 you're eliminating A, you need E, F, and G. So if you have choice, pick the one that you eliminate the least member on the type. You know, the least dimension that you need to eliminate is the what you use. Well, what about between 5 and 6? If you have that, choose the one with the smallest type, 5. Between 5 and 6, use 5. So that's how the rule is. Okay. The other thing, when you're detailing the types that you, sometimes I find the detailers having a hard time looking for a type because the shape that they're looking at doesn't really match the type. For example, I have a guy who had a hard time finding a type for a bar that looks like this. Oops. Oops. He had a problem with something like that because it looks like that. He didn't realize that if he flipped it over, it will look like this. So all the time, 12 was staring him in the eye, but he could not use 12 because it didn't appear like this one. Here's another problem. When you give a dimension, for example, like this C and D, right? Let's pick another one. It's real critical. And we're going to go to the detail of all these types and bending later on when we're actually detailing. Sometimes a detailer will give me a type that looks like this, and I'll try to draw it in scale. As straight as I can, like that. He will give me B and C, and then he'll give me the H dimension, like this one. So he gives me 2 feet for this, 10 feet for this, and he'll say this is 7 and say 8 feet. That is wrong. The reason it's wrong is because consider yourself the bender in the shop. You're given a bar that's 12 foot long, bend 2 foot 45 degree and 10 feet. And the dimensions you got is this one. In other words, you're going to keep this steady while you're bending this 10 foot bar from a straight, you're bending it to an 8 foot height. That is the wrong way to detail it. A good detailer will recognize right away it's easier to bend something like this. This is 10 feet. This is 2 feet. And this is only 1 foot something. That's easier to bend than this one because all you're bending is 2 feet. You're holding a bigger piece on the table. Here, your table might be, the funny thing about this one is your table might just be this big. Can you imagine? You're holding that on a table 2 feet, and outside the table is sticking out 8 feet. Well, here it's better because you're holding a bigger piece on the table and bending. So in this case, on this next one, the whole thing could be in your table, like that. Does that make sense? Okay, so that's all the thing about bending on types. And I want you to read all the thing yourself and learn a little bit more. But I think I touch on what is the most important thing. Then remember, you don't need to memorize all this. but it's nice to know it also. Mostly about detailer, because before, when we were detailing, there was no computer. We're obligated to memorize all this, and we all have that in memory already. Up to now, I could still tell you what the bend dimensions are. And if I don't remember, I can always, this is not like a school where you can cheat, you know, you can open your book and look at it. But I want you to look at this special thing. In seismic zone, when you're detailing for moment frame design or seismic design, there is a requirement in seismic for 135 degree hook, like this is also 135 degree hook. Number 3 bars on 135 degree hook is only 4 inch on a standard stirrup on ties. But when the number 3 bars is used for seismic, it's 4 1/4. So the number 3 bar is the one that is different. After that, everything is the same. So number 4 is 4 1/2, this is 4 1/2, 5 1/2, 5 1/2, 8, 8, 9, 9, 10 1/2. But the number 3 on seismic is 4 1/4, not 4. So if you have 5,000 stirrups and you detail it incorrectly, you use 4. They won't be able to use it because the requirement is 4 1/4. So you need to know and understand that there is this thing called seismic stirrup. All right, so read again. There's so many things. What is the mill stock length? How long are bars available? What are the length of the bars? In the United States, bars are available in 60-foot mill stock lengths. That's how it comes out from the mill, 60 foot long. Almost throughout the United States. In California, though, you could order them up to 80 foot long. Why is that? Why is California have 80 and the rest of the country only have 60? Let me see if I could explain this. California designed most of their bridges in reinforced concrete because we don't have snow like they do in the East Coast. In the East Coast, most of the bridges are structural steel. California is reinforced concrete. In fact, California is the pioneer in reinforced concrete bridges. All their bridges are in concrete. Because of this, bridges are normally long span, greater than 60 foot span. 80 foot is common. So California started asking for 80 foot bars. And because there's a lot of bridges being designed in California, the mill accommodated California and made 80 foot available. Only in California. If you go to New York, ask for 80, they tell you, we don't have a, we can order one from California, but the cost of trucking from California to New York might be too expensive. That's what mill stock length is. What are shop stock length? When the shop gets the 60-foot bar length, they know in the progress of detailing, they see a lot of bars cut 20 feet. That's very common to detailers. Rebar detailers detail length of bars not because of what is available, but what is convenient to work on for the iron workers. Iron workers doesn't like to carry 60-foot bars because they're heavy. They like to carry 30-foot bars. So when the 60-foot bars come to the shop right away cut them into 30-foot stock length. These are now called shop stock length. They're cut into 20 foot, which they use for masonry walls, 30 foot, and 40 feet. So 60 is cut 20, and the bar 40, that's stock. So The shop stock length comes now 20 foot, 30, and 40. These are available all the time from a shop. So when you're detailing, do not use stock 25. There's no such thing. Do not use stock 35. There's no such thing again. Use 20, 30, and 40 because that's readily available. The shop doesn't need to cut a 60 footer. They already pick it up. They already have a 30 footer, they already have a 20, and they have a 40. So they're pre-cutting them to save time. When they get a big job, all the straight bars are already pre-cut. But that's mill stock lengths against shop stock lengths. I'm not sure if it's in the book, but I thought I'd mention it to you. You could read some more in the books, and in fact, we're now getting exciting here. We go to 7, special bundling and tagging. Bars, bundle of bars. Straight bars are not given a mark. When they're tagged, it just shows the quantity, the size, and the length. They're not given a bar mark. Only bent bars are given a bar mark. So when a bent bar comes to the field, it's got a tag, shows the quantity, the size, and the mark, and the bar mark. Our software are designed so you could specify the bundling size. You could say, I want my bundles to go to the field in increments of 1 ton each. If I have several bars, I want you to bundle them 1 ton each bundle. Because the crane that is available at the job site can only carry 1 ton, or it can only carry 2 tons. So if you bundle it 5 tons, they're going to have to open up the bundle. So that you don't open up the bundle, you specify during detailing what size bundle you want. The tagging, this I will explain later also. The process of delivering steel to the job site is broken up into releases. They call it releases. Release 1, release 2, release 3, release 4. Releases is a sequence of how they're going to need it at the job site. For example, release 1 is needed first before release 2. So when they're loading the truck, they put the high number releases at the bottom and the low number releases on top, because that's the first one they're going to unload. So they unload release 1 because that's what they need first. Then 2, and then 3. If you loaded the truck in reverse, the iron worker is going to be pissed. He's going to be pissed and moaning, say, now he has to remove all the bars that are laid on top of what he needs. Just to get to what he needs, he has to unload everything. So there's a bit of logistics when you're detailing. And that's the beauty of detailing. The detailing is really, you have to be a genius. You're not only detailing the right size, the right amount, the right shape, but also playing with logistics. That when it gets to the job site, the things that they need first is available right away. They can unload, put that in the form, then the next one, and then the next one. That's special bundling and tagging. You will learn that. And then some more. See, there's quite a bit of things to read. I'm just pointing out the important ones. Bars, when they're sheared, are not square. When the bars are sheared, it looks like this. When you shear up a bar, it looks like that. The first sharp bite, and then the bar slides down. That's why it goes like this. So the shearing bar will hit it, go straight, and then it pushes the bar so it goes this way. Well, sometimes the engineer will say, I need this bar in column is in compression, and I need a mechanical lock, which is we call a G-lock. You put it in, and you put the two bars. Because it's in compression, it's just a simple lock. But to be effective, it has to be, the end of the bar has to be squared. It has to fit exactly square. If the rebar you're detailing needs a square cut, you have to specify it, and they will saw cut it. Not shear it, but saw cut it. They will put it in a machine and they'll saw it. They'll saw it straight. So that the two rebar, flush and square, will fully engage each other in compression. Not just one part of the rebar, but the entire face of the end of the rebar. See this one? This is the allowance is very small. Maximum deviation from square to the end. That's what they're saying. Loading limits, special items, all that. Oh, also, there's a fabrication tolerance. You need to know this also. These are the fabrication tolerance for a straight tolerance is number 2, number 2, number 2. What is number 2? Let's look. These are the tolerance. A tolerance number 2 denotes plus or minus 1 inch. Wow, that's quite a bit. So, which means, consider this. You're detailing something that is confined on both ends. And you detail them, you deduct 2 inch and 2 inch. So you came up with the concrete dimension is 10 feet. You deduct 2 inches on each side. Now you have 9'8". But when the bar came, it's not 9'8", it's 9'9". Now you can say, hey, this is not what I detail. I detailed 9'8". You gave me 9'9". The shopper says, well, tough luck on you, because I'm within my tolerance. My tolerance for a straight is 1 inch. So even if you say 9'8" and I gave you 9'9", you're stuck. You know, because fabrication is not a true exact science. Remember, it's a fabricating machine. There's a shopman doing it, and nothing is totally exact. That's why ACI and CRSI provided these tolerances. Not only there's a tolerance of material, there's also a tolerance in placing. What is acceptable? What dimension is acceptable? So you now tell the engineer says, oh, you cannot use that because I need a 2-inch clearance. Wait a minute, mister. According to this, I'm allowed to have a 1-inch tolerance. So instead of 2 inch, I now need 1.5 inches on each side. He's going to have to accept it. Rebar in the United States is priced by the pound. Just like in the Philippines, it's priced by kilogram. In the United States, priced by the pound. So it's always the weights that they're concerned about. But like in fabrication though, we notice that the weight is really not the factor in how they classify bending. So it's, remember, it's rebar is by the weight. Well, the other thing we need to look at is loading limits of bar. When you detail a certain rebar, you have to consider that the bars would have to be hauled from the shop all the way to the job site. You have to take into consideration that the rebar will be laid flat on a truck bed, and it should have this maximum right angle leg for shipping. oops, nope, not that one. Maximum arc length per shipping. So a radius bar has to have, in order for it to have a 7'4" maximum, has to have all these dimensions. A radius of 4 feet, the maximum length is 20'5", and the radius is 13'6". So these are the table that determines the maximum arc length. It's given here. Sometimes though you need a bar that exceeds this maximum limit. On a case like that, then the shipment will be on a special shipping. The truck will be escorted by other cars to get to their destination. It's a special, you have to have a special permit to hold the rebar. On a right angle bend, these are the table. This is the table they use, the maximum right angle leg per shipping. So in other words, if you have a shorter leg of 8 foot, the maximum length should be 18'4", and that will give you a 7'4" max. So it gives you, on a shorter leg, what is the maximum leg? Shorter leg, maximum leg. Shorter leg, maximum leg. This is for loading limits, strictly for loading limits. You see this problem mostly on big retaining walls, where you have a leg and a vertical height. The engineer wants it in one piece, and you tell the engineer that's not gonna happen because you won't be able to ship it. You could, but you're gonna have to ship it at night, and you're gonna have a special permit, and you'll have 2 cars escorting the big truck on each side. It's kind of expensive proposition. Field bending. There's a limitation of field bending. Reinforcing bars should not be field bent or strengthened in a manner that will reduce the strength or ductility of the bar. But there's some requirement that could allow you to bend it. For example, realigning number 3 to number 6. That's allowed, bars up to a 45-degree bend. So these are the rules on that. You gotta go read. You need to read all that thing. Also, there's a special machine that welds, not tack weld, but fusion weld, a holding wire into a set of stirrups, so that this set of stirrups becomes bundled together, and all you have to do is lay the beam bars inside. You don't need to tie that stirrup to the bars because it's already pre-tied by these holding wires. This method allows for a quicker way of assembling beam cages or column cages. Some of our customers have this idea machine, and it requires a special detailing from us. We have a video of this. Those of you who are new though, don't need to be concerned about this, because out of so many customers, very few have this idea machine. So don't worry so much about this. Oh, I forgot to tell you on tags. If I could go back to tags. Tags comes in different colors. You know, each fabricating shop have their color on the tags. You know. There are 10 colors available, all matching the last number of a release. For example, release 1 or 11 is color 1, release 2 is color 2, release 3. And let's see if I have a sample of color tags. I think what I have is from, oops, not that one, the one from Canada. If the last number of the release is 1, the color of the tag is white. Release 2 is red, release 3 is dark green, and on and on and on. Because it's color coded, now logistically it helps the iron worker pinpoint the bars that are going to be needed. He will direct his iron workers to unload all the green bars to that side and blue bars on that side. So that helps sorts out all the rebar. This is not practiced in the Philippines, so you don't see this in the Philippines. But in the United States, this is really used. Because in the United States, labor is so expensive. So the least amount of handling, double handling on the bars, the cheaper it gets. In the Philippines, they handle, double handle, triple handle the bars. If you go to a job site in the Philippines, you see rebar all scattered all over the place because they never use color tags. We have color tags in the United States. You don't need to worry about it because it's predetermined by the release number. So release 1 and release 2 will not have the same color tags. So right away they could distinguish release 1 from release 2 by just looking at the tags. That's easy. Okay, we're getting close. Okay, now field bending, lap splices. Now we're going to talk about lap splices later. Okay, we get rid of this one. Oh, also, how many of you knows that rebar does not only come in straight rods? In the Philippines, all you see of rebar are straight rods. It just comes straight bars. In the United States and all around the world, rebar also comes in coils. The rebar is coiled. Here's a sample of that. Where is that sample? There. See, the rebar is in a coil. Because it's in a coil, it has less waste, less remnants, less scrap. In the Philippines, rebar comes 12 meters. So if you cut a length from a 12 meter, you will end up with one remnant every 12 meters. That's why there's a lot of scrap in the Philippines. For every 12 meter that you need, you cut them up, you end up with maybe half a meter or 1 meter or 1.5 meters, which very seldom you can use. So you throw it away as scrap. Because this is in a coil, when you cut this, you will only end up with one scrap for every 3,000 feet of coil, 3,000 feet of rebar. The coils comes from number 3 to number 6 bar. In Europe, it even goes higher than number 6. It's got number 7, 8, and I believe number 9 also. The Europe are more advanced as far as rebar and the equipment. The only bad thing about coils it requires a straightener, because you cannot use it to reinforce a slab because it's a coil. But if you have a straightener, you run it through a straightener, it'll come out straight, just like a straight rod. And the coils is also deformed. It's plain or deformed. Again, it could come number 6 bars, 3/4 inch thick. So most of the small size bars, 6 and under, are in coils. Less waste. We have the only coil in the Philippines. If you go to our shop in Parañaque, we have, I don't know if any one of you know, we have we're introducing rebar fabrication in the Philippines. We have the equipment, we have the straightener, and we have the coils. Coils is not available in the Philippines, but I found them in Taiwan, so I bought a lot of coils from Taiwan and I brought it to the Philippines, and we're selling them. If someone wants us to do stirrups, we have a machine that spits stirrups like crazy without a guy touching it. You should see that machine. We invite you to go to the shop. Anyway, we're very close. Now, I want you to go to Appendix 6. Read and study it. In the absence of a specific design details, you will find Appendix 6 very helpful. Appendix C, I'm sorry, Appendix C. This is Appendix C. In Appendix C, it tells you absent the specific design detail, what are the rules for spacing a bar? In a slab, beam and slab, the slab rebar, given the spacing, to find out the quantity of the rebar, you start the first spacing. One full space from the base of the beam is your first bar. And it ends one full space away from the base of the beam. Not at the base, but a full spacing. That's the rule of the jungle. If an engineer sometimes doesn't know this rule, and he will say, oh, I want half a space. I said, where did you learn that? You show them this. It says, the rule of CRSI says a full space. Not half a space, but a full space. So you need to know this if you want to be a good detailer. That way you're not giving extra bar. Because the iron workers knows this. When you give him a bar, he starts away full space. And then if you gave him a little bit more, he says, hey, you have one extra bar. Because you space it half a space, he space it full space. So it's important to know this. That's on a structural beam, say full space, full space. Okay, now look at the difference when it's masonry. If the support is a masonry wall, you begin at the end of the concrete. You begin at the end of the concrete. There. Oops. I'm hitting, you see there, all the way to the end. If it's a metal deck, you begin with the first flute. And you skip the flute right above the beam. That's how you determine quantity on a slab. This applies to slabs, wall, mats, or footings. Full space, all that. On walls, here's what happened on walls. At the corner, you begin at the first corner of the wall, all through the. If there's an opening, you stop. And inside at the corner. That's why if the wall is springing at several corners, sometimes our detailer have a tendency to say 200 bars each space when it is going into several corners. That is not so, because always the inside face has less rebar than the outside face most of the time. So you really have to determine it. But it doesn't hurt though if you give them both. If you have a column, look, one full space from the vertical bar of the column is when you begin your bar. You end the bar, one full space to the vertical bar. This is a plan view of a wall. Horizontal bars on a wall, half a space at the bottom of at the soffit of the slab. And from top of footing, half a space. You begin the horizontal bars, half a space. Yeah, you begin the bars, half a space. On precast wall panels, like tilt-up walls, you begin specified cover, and then the spacing. On column pads, wall footings, you begin from the side of the footing, half a spacing, and then space them. Same thing on the top, half a spacing. So if you have a 5-foot wide footing and the spacing of the bar is at 12 inches on the center, you only have 5 bars, not 6 bars, only 5. In flat plate design, slab, where you have a column strip and a mid strip, like the column strip, here's the center line of the column strip. You do not have a bar right on the strip. You have half a spacing on each side. These are the column strip bars, and outside this is the mid strip bars. So it's important that you know this. Column pads, mat foundation. Whenever you have a joint, pull space. Up a space at the end. And on and on and on. This is almost to the last end of the page. From here on in, I want you guys to read through, study it, keep a copy of the MSP as your reference. I've been detailing for over 40 years, and I still keep a brand new copy of the MSP, and I always refer to it because there's no way in the world I could memorize all the rules in this book. So I always update myself by reading it from time to time. Even though I've read it so many times before, I will reread it and reread it because I want to master it. All the mistakes that detailer does happen because they never really understood the Manual of Standard Practice from CRSI and ACI. This is very important. You need to master this. This is Rebar Detailing 101. Other lessons after this will deal with detailing itself and all the intricacies of detailing. But the Bible is the Manual of Standard Practice. Master this one. That's it. Thank you very much. Bye-bye.